Hello everyone and welcome to PYQ Diary. In this session, we're jumping right into 20 really important physical science questions from previous Odisha B.Ed exams. So whether you're deep in your prep or just want to brush up on your concepts, you are in the perfect place. Let's get started.
Okay, so here's our game plan. We've split this into two parts. First, we'll tackle 10 questions focused on physics, and then we'll switch gears and dive into 10 questions all about chemistry. All right, let's dive into the physics section. These first few questions are really going to check our understanding of the basics. Mechanics, waves, and a bit of electricity. Ready for the first one?
Question number 1. So we've got two equal masses on a spring, and they're stretched out by a length x. The question is, what's the work done by the spring on each one of the masses? The options are A, B, C, and D. And the correct answer is D. So the trick here is to remember that the total work done by the spring is always negative. It's negative 1/2 kx squared. But since that work is being done on two identical masses, it gets split right down the middle. You just divide by 2, and that gives you negative 1/4 kx squared for each mass.
Question number 2. An empty box accelerates up in the water. How much sand do we need to add so it accelerates down at the exact same rate? The correct choice here is A, 2m/5. This is a cool little two-part puzzle. First, use the fact that it's accelerating upwards to figure out the buoyant force from the water. That force stays the same. Then you set up a new equation for it accelerating downwards to find the total mass you need. After that, it's easy to figure out how much sand you gotta add. Question number 3. We have a scooter riding away from a siren, and there's wind blowing in the same direction. What frequency does the rider hear? The correct answer is A, 583 Hz. Now, this is a classic Doppler effect problem, but with a little twist. You have to account for two things. The scooter is moving away, and the wind is giving the sound waves a little push. So you just have to adjust the speed of sound in the formula to include that wind speed, and you'll get the right answer.
Question number 4. In a double slit experiment, we cover one slit with a thin sheet. How many fringes are going to shift? The answer is B, 18. Don't let all the numbers in the question scare you because this is actually a straight-up formula problem. The number of fringes that shift is just the refractive index minus 1 times the thickness, all divided by the wavelength. You just plug in the numbers, and the answer pops right out.
Chali, next question. Number 5. What's the pressure at the very bottom, right in the center of a hemispherical bowl full of liquid? The correct answer is A, rho gr. This all boils down to the basic pressure formula. P equals H times rho times G. The only thing you need to realize is that for this specific shape, a hemisphere, the depth h at the very center is just the radius of the bowl r. Easy peasy.
Question number 6. A charge Q is sitting right in the middle of a cube. What's the total electric flux through all 6 faces? And the correct answer is B, Q divided by epsilon naught. This is where Gauss's law is your absolute best friend. The law basically says, hey, I don't care what shape the container is. If it's closed, the total flux is just the charge inside divided by this constant. It's that simple.
Question number 7. We take a 50-ohm wire, cut it into 5 equal pieces, and then connect those pieces in parallel. What's the new resistance? The answer is A, 2 ohms. This is a super simple two-stepper. First, you chop that 50-ohm wire into 5 parts, so each part is now 10 ohms. Second, when you connect 5 identical resistors in parallel, you just take the resistance of one, 10 ohms, and divide by how many there are, which is 5. So 10 divided by 5 is 2. Done.
Okay, question number 8. A charged particle zips through the center of a circular wire that has current flowing through it. What's the magnetic force on that particle? The answer is D, 0. This one is all about symmetry. Think about it. The current comes in and splits perfectly in two, one half going over the top and the other half going along the bottom. The magnetic field from the top half is perfectly canceled out by the magnetic field from the bottom half. It's like a perfect tug-of-war right at the center. No net magnetic field means 0 magnetic force.
Question number 9. A diatomic gas does 200 joules of work while expanding at a constant pressure. How much heat did we have to give it? The correct answer is A, 700 joules. So for this specific situation, a diatomic gas at constant pressure, there's a really handy little formula to know. The heat supplied Q is just 7 divided by 2 times the work done W. Just plug in 200 for W and you get 700.
And our last physics question, number 10, what voltage do we read across 2 railway tracks when a train is speeding along at 180 kilometers per hour?
The correct answer is D, 1 millivolt. This is a motional EMF problem. The formula itself is super easy. E equals B times V times L. But, and this is the big but, here's the trap everyone falls into. You have to convert that speed from kilometers per hour to meters per second before you do anything else. Don't forget that step.
All right, physics is in the bag. Let's switch our brains over to chemistry mode. For these next 10 questions, we're going to be looking at things like atomic structure, chemical bonds, and some classic reactions.
First up for chemistry, question 11. For the N shell of an atom, how many possible combinations of quantum numbers can we have? The answer is D, 32. The magic formula you need to remember here is 2n squared. The N shell just means the principal quantum number n is 4. So you plug 4 into the formula, 2 times 4 squared, and boom, you get 32.
Question 12 wants to know which of these molecules has the highest dipole moment. The correct answer is A, CH3Cl. Okay, first thing, let's just eliminate CCl4. It's perfectly symmetrical, so all the little poles from the chlorine atoms cancel out, giving it 0 dipole moment. Among the others, CH3Cl packs the biggest punch, because that one powerful chlorine atom isn't having its pole weakened by other chlorines pulling in different directions.
Chaliye, next question. Number 13. Which of these has unpaired electrons? The correct answer here is C, O2-. Now, you could draw out the whole complicated molecular orbital diagram, or you could use this awesome shortcut. Just count the total number of electrons in each one. If that total number is odd, then it absolutely has to have an unpaired electron. Simple as that. And O2- is the only one here with an odd number.
Let's look at question 14. Which of these is a hard acid? The answer is A, Cr3+. A good rule of thumb for this is to think of hard acids as small ions with a high positive charge. Chromium, with its +3 charge, fits that description perfectly. The other options are bigger ions with only a +1 charge, which makes them classic examples of soft acids. Question 15 is all about knowing what the Bohr model can and cannot do. So, what can it explain? The correct answer is B. This is really about the model's biggest weakness. It works like a charm for anything with just one single electron, like a hydrogen atom or a helium ion. But the second you try to use it for an atom with 2 or more electrons, the whole thing just, well, it falls apart.
Question number 16. What is the HOMO of carbon monoxide? And the correct answer is A, a sigma bonding orbital. HOMO sounds a little weird, right? But it just stands for highest occupied molecular orbital. Think of it like the top floor in an apartment building that still has people living in it. For CO, that top occupied floor happens to be a sigma bonding orbital. For question 17, let's look at this reaction. What's going on with the phosphorus? The answer is C. It's being both oxidized and reduced. This is a classic example of a disproportionation reaction. It's just a fancy term for when the very same element does both jobs at once. See how phosphorus starts with an oxidation state of 0? And on the product side, some of it is at -3 and some is at +1.
Question 18. In which of these molecules does the sigma bond have the highest S character? The answer is A, acetylene. S character is all about the hybridization. Acetylene has sp hybridization, so it's a 50-50 split, 50% S character. That's way higher than ethylene, which is sp2, so it's about 33% S. And methane is sp3, so it's only 25% S. Acetylene is the clear winner here.
Question 19 asks about the structure of perchloric acid. For this one, you really just have to roll up your sleeves and draw the Lewis structure. Put the chlorine in the middle, surround it with the 4 oxygens, stick the hydrogen onto one of them, and then start adding double bonds and lone pairs until all the atoms are happy. If you count everything up correctly, you'll land right on option A.
And our final question, number 20. If the energies of 2 photons are in a 3-to-2 ratio, what's the ratio of their wavelengths? The correct answer is B, 2-to-3. This is based on a super important relationship in physics. A photon's energy is inversely proportional to its wavelength. They're like a seesaw. When one goes up, the other has to go down. So if the energy ratio is 3-to-2, the wavelength ratio is just the inverse, 2-to-3. इसका आंसर आपने सही दिया क्या?
And that's a wrap on our 20 questions. अगर आपको ये PYQ सीरीज पसंद आए तो लाइक, शेयर और सब्सक्राइब जरूर करें PYQ Diary चैनल को. Thanks for studying with me today and I'll catch you in the next one.